Testing Spring application. In this presentation, we are mostly focused on unit testing. So these are the set of topics we are going to cover. So we are going to take a look at testing support in Spring Framework, and we are going to see how you can do unit testing without using DI first, and then we are going to see how you can use Spring dependency injection in your testing. And then we are going to take a look at test context framework in Spring, and then we are going to see transaction aware testing. So this is useful whenever you are testing that involves some database access. You always want to actually start with a clean slate, right? So this is something you can use what is called the transactional annotation in your testing environment to roll back any database changes you made. We are going to also see how we use Mockito as a mocking scheme, and then we are going to see how we can do unit testing for Spring MVC application. We are going to see some testing annotations you can use in testing code, and then integration testing. In fact, we are going to do a separate presentation on integration testing, so we are going to cover these topics in this presentation. Testing support in Spring Framework. So just talking about the concept of unit testing versus integration testing. Unit testing is, well, here we are going to use a dependency injection in unit testing. Same thing with the integration testing as well. Integration testing involves multiple layers. For example, controller method invokes a service method, and which in turn calls a repository method, which in turn calls the data storage layer method. So integration testing involves multiple layers. But integration testing lets you test these multiple layers without requiring deployment of the application to actual database server or application server, or connecting to an enterprise infrastructure. So this is really nice thing. You can still test the multiple layers without the actual deployment of the application server, meaning you don't have to have an application server up and running to do that. Okay, so we can actually talk about that concept, integration testing, in detail in a separate presentation moving forward. Okay, so unit testing with the dependency injection. So dependency injection makes your testing code not requiring a container. So basically you are going to have any dependencies to be injected by the testing framework instead of the container. So typically in the production environment, you are going to use a container to provide dependency object, right? But in testing environment, you are going to use dependency object that get created by the testing framework. And POJOs that make up your application should be testable in JUnit or testng test. So Spring support both JUnit and testng, and we're going to actually experiment with both. So in this case, test target objects are created with a new operator because they are POJOs. You should be able to create your target object with just like any other POJOs using new keyword without using or any other container. So because those are POJOs. And true unit test should run pretty quickly, extremely quickly. So there is no run, because there is no runtime infrastructure set up. And again, doing unit testing is a really good thing for your application development methodology. Eventually, it will boost your productivity. Kind of obvious things. Okay, unit testing with the dependencies. So Spring providing this clean layering and componentization of your code base, and basically you can use the mock objects again created by the testing framework injected in your code. And so you can test, so you can test service layer objects which have a DAO or repository dependencies by mocking DAO and repository interfaces without needing to access real persistent data while running unit tests. So if you have a service code, which typically depends on DAO interface or repository interface objects, those objects could be mocked. So we are going to actually do the lab mocking these things using Mockito. Okay, so obviously you want to perform unit testing using dependency injection. If you are not using Spring dependency injection, then yeah, so that's something we're going to talk about in this segment of the presentation. I'll give you a example code. So test code, JUnit 4 improvement over JUnit 3. So nobody seems to be using JUnit 3 anymore, so this is probably a moot point, but just to give you a sense of the difference between JUnit over JUnit 3, test class no longer needs to extend test case anymore. You're gonna just use the annotation. Test methods no longer need to be named as test and name of the method. Instead, you're gonna use @test annotation. And setup and teardown method no longer have to be named as a setup and teardown. Instead, you're going to use a before and after annotations. Okay. By the way, in Spring 4, JUnit 3 test is in fact removed. Okay, so this is the JUnit 3 base code. You have to extend the test case class, and then you have to have a setup method, and then every test method should start with a test like this. Okay. So in JUnit 4, those constraints are gone. So basically, in order to have a setup method, basically you are going to annotate with @before annotation, and you can name it in any way you want. And this method gets invoked before any test you do. So, and the test will be annotated with @test. So your method does not need to start with a test prefix. Okay? So you can name it in any way you want, as long as you annotate it with @test annotation. This is the case for testing the exception case. So when you're running this method, it expects illegal argument exception to occur. Okay, so this is catching the exception case. TestNG has pretty similar annotation, so it has a before method that is a similar thing to before in JUnit. It also has a test, same annotation, and after method is the same as after annotation in JUnit. The one nice thing about TestNG is that it does have what is called the data provider annotation. It actually enables data-driven testing. So basically, this annotation makes a method a supplier of test data for test methods. So I'm going to give you an example in the following slide. So why don't I actually use the example here? So we have TestNG test using data provider. So we have before method that gets invoked for every test. Now we can actually create a test data set. So here, data provider, we are going to name this set of data for legal testing, and this is for illegal testing. So whenever we are providing a data from this illegal testing, it should actually cause an exception. Okay, so in TestNG, data provider annotation is used to provide test cases. Okay, so suppose we have this data provider with a legal data set and illegal data set. Okay, and then what we can do is that for the testing, we can use the we are going to use data provider legal. So basically we are going to use data set defined in legal data provider here, and then we should be able to test it. And this is a case that we are using illegal data set, and this should cause illegal argument exception. Okay, so one nice advantage of using TestNG over JUnit, because it provides data set, the annotation called the data provider. Okay, so let's actually try with unit testing without using Spring Framework dependency injection. So exercise 2, we are going to actually use the dependency injection. So let's take a look at the exercise 1. Okay, so we are going to first of all, we are going to install TestNG, because Spring STS does not come with the TestNG plugin. So we need to install it. It comes with the JUnit plugin, so you don't need to install it, but TestNG you have to install it. So you're gonna go to Help and install new software. So you're gonna go to Help, help and install new software, and then you're going to specify the location where you can get the TestNG plugin. So you are going to copy this URL and then specify workgate here, and then if you click, then you're going to see TestNG. Okay, and then you're going to go next, and then you're going to install it. Okay, so since in my case I have already installed, I'm going to just stop the process. I'm going to just cancel it for now. Okay, so in your case you're going to just install it. Okay, alright, so we are going to restart the STS after installation. Okay, now I'm going to actually go for perform testing of testing calculator, and we are not using Spring context or dependency injection. So here we are going to take a look at the Spring test code here. So there is a project called the testing calculate no Spring context project. Okay, so if you take a look at the code, this is the our testing code. This is the not testing code, testing target code. Okay, so we have interest calculator interface, and then we have the actual implementation of it. It's a very simple code. Okay, so we have simple interest calculator implementing this calculator interface, and it does have a calculate method and a set rate method. Okay, so we are going to write a testing code for this calculator. So it will basically compute amount and year, and it basically returns the amount of money that you have to pay. Okay, using year and rate. Okay. Alright, so if you take a look at the testing code, okay, so we have in fact the three different testing code. One is using JUnit 3.8, and the other one is JUnit 4 and JUnit TestNG. Okay, so we're gonna just run this JUnit 4 and TestNG case. Okay, so right click and run as, and then JUnit. And this should succeed. Okay, and that should succeed, and this one also should succeed. This is the case that we are using TestNG. Okay. Okay, so TestNG also succeeded. Okay. Alright, so let's take a look at the code. Okay, so let's study the code. So this is the testing target code. So testing target code, as I showed you, this is interest calculator interface, and this is the implementation of that interface. So the logic that we want to test is, maybe the calculate. Okay, so if you take a look at the JUnit 4 testing code, okay, so we have before and one single test method and another test method, and we are going to check whether illegal argument exception gets occurred. Okay, now because we are not using dependency injection, we have to create this target test object ourselves. We have to use new and simple interest calculator object. So we have to create ourselves. Okay, TestNG code is the same thing. We have to create the simple interest calculator object ourselves, and then we actually provide, in this case, test provider, legal set and illegal set. Okay, and then we are doing with the legal set and illegal set, and they all worked fine. Okay, all right, here I'm gonna ask you to modify the project. So create compute service interface as following, like you're gonna have compute and create an implementation class and perform the testing. Okay, All right, so the exercise you just did was the case that you are not using any Spring Framework dependency injection. Now we're going to actually use dependency injections. Before we do that, let's talk about the Spring Test Context Framework. So the Spring Test Context Framework was introduced from 2.5, and so basically unit and integration testing support is now provided in a form of annotation-driven Spring Test Context Framework. And this Spring Test Context Framework is agnostic of any actual framework to use, meaning you can use any testing framework of your choice, such as JUnit, TestNG, or if there is any other testing schemes, yeah, you can use those things with a Spring Test Context Framework. Okay. Okay, so there are a few the abstraction in test context framework, test context manager, and test execution listener. So you don't really have to know these things in order to use Spring testing framework. It's just for reference. So each test context provides Spring test context management and caching support for test instance for which is responsible. What that means is that, if you remember the Spring dependency injection presentation that we have done on the first day, basically, when you're starting your application, Spring context object gets created, and the context object is basically registration of all the beans. It figures out what bean is needed, and it will instantiate those beans, and then it will perform the wiring and configuration, right? So that is actually represented by context object. Okay, so when you're doing a testing, so you're basically running multiple test methods. And so what you want to do is that you want to have the same context object to be available for each of those test methods, right? So what it does is the test context framework will actually manage to run those configuration, meaning context is created, and then it will cache it for each of those test cases. Okay, so for each method, it will have a fresh context object. Okay, that references to all the beans and their configuration, things like that. Okay, so reading configuration file, component scanning, bean creation, bean wiring, and caching them for subsequent testing. So that's what the test context framework is handling. Okay, so test instances do not automatically receive access to configure this application context object unless you have two choices. You can extend Spring provided support class. That's one way of getting the application context object that was created. Or you are going to configure Spring provided test runner. So either option is okay. Usually this option is more popular, is actually more widely used. Okay, but this is only available in JUnit 4.x. All right, so let me actually talk about the first case first. So, the extend Spring provided support class. So let's talk about it first, and then we're going to actually see how you can configure Spring provided test runner. Okay, so Spring provided test context support classes are abstract JUnit 3.8. This is JUnit 3.8. So let's actually, forget about this. We're going to just mostly focus on JUnit 4.5 and TestNG 5.10. So this is the support class, abstract JUnit 4 Spring context test class and abstract TestNG Spring context test. So just by extending these classes, you can now take advantage of Spring test framework, okay, without knowing the details of the framework. Okay, what it means is that when you actually extend these classes, when your object gets created, basically these classes will have all your context management to be done for you. Okay, all right, and in this case, test runner is also pre-configured with the above classes, so you don't really need to configure test runner yourself. So let's see an example. So this is so I'm gonna actually move forward with the JUnit 4. So here you specify context configuration, and you can actually specify any configuration file of your choice. Okay, it could be XML file or it could be Java configuration. So in your case, you have a testing code here and extends abstract JUnit Spring context test. So by just by extending it, you are now taking advantage of Spring Test Context Framework. Okay, so this is for JUnit, and this is for TestNG. So here you are going to extend abstract TestNG Spring Context test, and then all the dependency injection schemes are available to you. Okay, now another method, another scheme that you can use is using test runner. So if you do not want to extend Spring provided test context support classes, as you have seen here and here, and that's usually the case, you don't want to extend these classes. That's a bit more inconvenient. Instead, what you can do is you can use this run with annotation. So here, run with Spring JUnit 4 test runner.class. This is typically what you see in most of the testing example code out there. Okay, so let's see an example here. So here you are going to say run with, and then you specify Spring JUnit 4 class runner.class. Okay, and so your test code does not need to extend any classes. So again, this is more popular the case. Okay, so the key point is that just by using this run with annotation, you are now able to take advantage of test context framework. Okay. All right. So now let's do exercise 2. So in exercise 1, we did not take advantage of dependency injection. So we were not able to take advantage of the context management of the Spring framework. So we had to create target testing object ourselves using new keyword, right? Now, by taking advantage of Spring framework context management, dependency injection management and all that stuff, now we should be able to get the target object using dependency injection. Okay, so that is exercise 2. All right, so let's go to exercise 2. All right, so we are going to run this code, now test calculator, now using Spring context. So again, it is exactly the same code. Target code is exactly the same, but the test code. Okay, so we are going to run this guy. We are going to actually run the JUnit 4 and TestNG 4. Okay. Yeah. So this is the case. This is the case that we are extending this Spring supported class. Okay, and this one should work fine. Okay. Now, in this case, the key point is that we are injecting interest calculator object. So this is the target object that you are trying to test, right? So we are using auto-wired now, because now we can take advantage of dependency injection of the Spring framework. Okay. Now you don't have to create a new simple interest calculator anymore, because that should be injected right here by the context framework. Okay, so now let's actually run the test, and test should just run. Okay, JUnit. Okay, so that has been successful. Now let's take a look at the example where we are now using run with annotation. So instead of extending the class, we are going to use run with the scheme. So again, this is most popular. Okay, so from this point on, we are mostly focused on the usage of this scheme. So run with Spring JUnit 4 class runner.class. Okay, so again, here we don't have to create our target test object, because that gets injected by using auto-wired. Okay, all right, so here we are going to do the testing, and that should work pretty much the same. And JUnit, and that was successful. And this is the case of we are using TestNG. When you're using TestNG, you don't have an option of running the run with option, so you have to extend the supported class. Okay, so again, the key point here is that you don't have to create target test object yourself. Okay, instead we are depending on the dependency injection scheme of the Spring Test Context Framework. Okay, all right. Okay, so now so basically Spring application configuration here. So this is where you are specifying the configuration class. Okay, same thing over here. Okay, so we specify the configuration class. It could be XML file or it could be Java configuration file. So if it is the Java configuration file, you specify classes, and then you can actually specify multiple of those using braces here. Okay. All right, so this one also should work. So let's just run it, run as and test ng, and then you should actually just make sure. So this is the exception case. I say, don't worry about it. So what's important is how many tests are run and how many failures they have. Okay, this is basically so that's basically illegal case. All right, so that is an exercise. So let me see. We've done all this. Okay, so again, the key point I emphasize here is that you don't have to create a test object yourself, because you are depending on dependency injection scheme of Spring Context Framework. Okay, again, this is more typical. Run it. Okay. All right, so so I'm gonna let you do the exercise here. You're gonna actually modify the project, and again, you're gonna actually have this compute the method to be tested. Okay. Next topic is persistence transaction-aware testing. So let me explain what I mean by that. So basically, after each testing, if the test involves the database access, or if in fact the test changes something like add an item or update an item, what you want to do is you want to roll back the result of that test so that the subsequent test can start from scratch. So that's basically persistent transaction-aware test. Here you can just use the add transaction annotation to roll back anything that has happened to the database on that particular test. So the changes in the database made in the current test method will not affect the subsequent test. So there is no need to write cleanup tasks. Okay, so basically create and roll back transaction for each test method. Okay. So one option is you can extend transaction-aware support classes to build transaction-aware test, or scheme number 2 is you use add transactional annotation. So this annotation has a different meaning in the testing environment. It's basically you want to roll back anything that happened to the database. Okay, so scheme number 1 is pretty similar to the one that we have seen before. You are basically extending these support classes: abstract transaction JUnit for Spring Context Test, abstract transaction test-ng Spring Context Test. Okay, just like again, this is rarely used, so we're gonna mostly focus on scheme number 2. So here, what we want to do is, if you can see this guy, test save order with items. So this is basically, we get the session. So basically, we are saving an item, which means that it changed the database, right? So database has been changed, and when you do have another test after this, you do not want this database to be changed. So here you are using transactional, meaning whatever changes that happen to the database will be rolled back. Okay, so that subsequent test will start from a clean state. Okay. All right, so here let's do exercise 3. Okay. Okay, so this is the so you're gonna actually try let's see, which one is this exercise we want to. So I want to go to exercise 3. That's a persistent transaction aware. Okay. Looks like my link is incorrect. Okay, so I have to go exercise 3 here. Okay, so we're gonna try testing transaction JPA transaction project. Okay, so that is this project. So let's run this guy. So we're gonna actually JUnit test, and it all should succeed. Okay, now if you take a look at the code, okay, so they all should succeed. Okay, so they all succeeded. So let's take a look at the test code. So here we have, in this case, we are going to test repository class. So if you take a look at the repository target class, so we have the JPA account repository implementation class. So here we are using JPA entity manager. We have a find by and we have an update. Okay. And so we are going to take a look at the account repository test Java here. Okay, so if you take a look at this test code, we have a 3 tests. Okay, so you can see account repository is injected, and we have the first test, second test, and the third test. Now, this first test doesn't change anything on the database. Basically, the only thing it does is just find this account 01, and to make sure when you actually perform the find ID, the ID of the account that was returned is in fact the correct one. So basically checking whether ID is correct. Now, this one is testing update. So here we get the account object, and we get the balance, and we are going to change. We are going to change the balance. We are going to actually update the amount of money. So here amount of money is set to 300. Okay, and then we are going to actually find that object again, then updated it. Okay, so that should change the database. Now we are going to actually get that data, and then we are going to see whether the balance is in fact correct. So we are going to get the balance by calling get balance, and then we are actually checking the balance is correct amount. Okay. So in this case, it actually changed the database, right? Okay. So now the next testing is this. So again here, next testing is we are going to get the account, and we still want to make sure that account still has $1,000. Okay. So that is the initial amount. Okay. So in order to have the changes that have been made in this test update and in the update method, well, in this actually testing case, to be rolled back, we are going to use a transaction, so that this one still remain 1,000 because this guy is getting started with a clean slate. Okay, so now let's actually try this. You are going to, let's say, comment this guy out. Okay, so suppose you are not going to use the transactional. That means when you perform this test, the account balance is going to be reduced by $300. So it's going to be remaining as $700 because we actually made a change. Okay, so let's actually try to test this guy. So I'm gonna just save this guy, and then let's try. We are gonna just try that test, JUnit test. Okay, now let's see. You can see JUnit. This guy failed. Test update. Okay, it's because it checked the balance is $1,000. Okay, but turned out to be it is $700 because the change that has happened over here is permanent. Okay, so just for the sake of the testing, we can just change to 700 to see whether that works, right? So let's run this guy, JUnit test. And now it should be successful. Oh, why it still fails? The balance, yeah, I'm not sure balance is the get balance. Yeah, should get balance. I'm gonna just print out the get balance to see what the values of this guy. Okay, let's actually run this guy, see what happens. And run as JUnit. Oh, so $1,000. Oh, that's interesting. $1,000. So that was actually initially $1,000. So that is interesting. So we have this transaction is commented out. Now let's see. I'm a bit puzzled on the behavior. Yeah, it's $1,000 and it fails. T equals get balance. Yeah, I'm not sure why it actually failed. Oh, it actually failed in the update, not actually on this guy. Okay, so that's why it actually failed. I'm not sure. Okay, so I'm gonna let you do the exercise first, and then I'm gonna actually look into a bit. So basically, that is what the transaction is all about. Transactional is all about. Okay, transactional, and yeah. So we got the error. It should actually run fine. I'm gonna give you 5 minutes to try this exercise. Okay, so let's move on to Mockito. So before we use Mockito for the unit testing, let's do a bit of tutorial. So what is mocking? Mocking allows you to test the class in isolation without having to have a real dependency object. Instead, your dependency object will be mocked using this mocking scheme. In our case, we are going to use a Mockito. Okay. A class may be dependent on many other classes, meaning the class will have dependencies, and those dependencies will be mocked. So in mocking, we replace these dependencies. By the way, we sometimes call those dependencies as collaborators. So we are going to replace those dependency objects or collaborators with mock object that essentially simulate the behavior of those the dependency object or collaborators. So a mock object is a dummy object in which you define the dummy output of a certain method call. So that's basically what the mocking is all about. So two popular mocking schemes out there in Java community include EasyMock and Mockito. So we are going to use Mockito in this hands-on lab exercise. Now let's talk about the classic 3A test architecture. So this is before we understand what Mockito is working. So you basically arrange the test and you perform some action, and then you see whether the result of action is expected. Is actually the same as what you expect. Okay, so these are 3A test structure: arrange, act, and assert. Okay, so this is an example. So suppose you have a target you need to test. So you are going to have a target object. Okay, so typically we're going to get this one injected in Spring Framework, right? Okay, if you're not using Spring Framework dependency injection, you have to create a target object, as we have seen. Now we have a dependency object, meaning this target object will have a dependency to this dependency object. Okay. So what happens is that when you are calling a method of your target object, in this case you have to actually pass this dependency object, because that dependency object is going to be invoked within this do something method. Okay, and then it will actually have some actual result, and then you compare whether that actual result is the same as expected result. Okay, so this is basically a classical 3A test where dependency is involved. Okay, so now let's move on to Mockito APIs. So Mockito, you can in fact simulate the behavior of that dependency object. So when dependency object method, suppose there is a method called in a dependency object, when that method is called, it should return something, or it should return some kind of exception. Okay, so this is a method you can use to train, or you can simulate the behavior of your dependency object. You also want to verify whether that dependency object is invoked. okay, with the correct argument. So you want to call verify, and you provide a mock object, and then this is a method and arguments, and you want to make sure that dependency object is in fact invoked correctly, okay? Because if the dependency object has not been called, then all the testing goes to moot, right? Okay, and then there is also what is called a mock annotation. So this is for creating a mock object. So let's take a look at an example. So in this case, we have this target object that we want to test. And the way you are going to create a mock dependency object is using this mock method. So you provide a mock method, and then you're going to provide a dependency class, and then it returns a mock object, which is a type of dependency. Okay, now you want to actually you want to actually train your mock object. So in fact, I should actually say mock dependency here. It's actually a mistake here. So when mock dependency object is called, there is a method called the is called, then we want to return, in this case, true. So we want to train this dependency object's behavior, meaning dependency object is called. Okay, method, if is called method is invoked, we want it return to true. Okay, so we train our dependency mock object to behave this way, and then we are going to call our target test object some method, do something method, passing in this case mock object dependency, because this is actually being used internally by our target test code. Okay, so we got the actual result, and then we want to actually compare actual result is actually the same as expected result. And now finally we want to make sure that your mock object is in fact called. Okay, and so the basically making sure that mock object method that we train has been in fact called. So in fact you have several other options like called once or twice or things like that. Okay, so this is basically how you're going to use a Mockito, okay, to simulate the mocking of your dependency object. Is this clear? Yeah, so if you're not familiar with this mocking, it might look a little bit kind of strange. Okay, so now we're going to actually move on to Spring MVC unit testing. So here we are going to use in fact a Mockito to create a mock object. Okay, in Spring MVC, again, unit testing, here's controllers. The controllers are pointers, so you can test them just like any other pointers. But controller has a typically dependency on, let's say, service object, right? So we need to have those service object to be mocked. So here we are going to inject mock dependencies using your favorite mocking library. Again, EasyMock or Mockito. Also, it does actually provide HTTP Servlet mocks automatically for you. So you can use this mock object if you want to. So there is a mock HTTP Servlet request, mock HTTP Servlet response, and mock Servlet context object. Okay, so these are provided for you if you want to use it in your testing code. Okay, all right. So let's move on to integration. Yeah, so we're going to actually talk about integration testing in another presentation. Okay, so Spring MVC testing framework lets you perform integration testing without deployment into an actual application server or without running the actual servlet container. So it provides the excellent alternative to unit testing. So as you will see later on, the integration testing is a lot simpler to use because you don't have to create the mock objects anymore. Okay, so in general, I personally find integration testing is a lot easier to write, and that actually means you are more inclined to write testing code. Using mocking is in your testing code is kind of cumbersome, as you actually seen in the previous slide. Okay, all right. So moving forward. So anyway, so let's see how we can use a Mockito in our controller test. So here we created, we have a testing code, so we're going to call it account controller test. So we are testing account controller. Okay, so on the top we have a run with method running the test runner, and then Spring application configuration. So again, we are using main configuration.java file, which is a configuration file in the testing target code, and then web application here. So here we created, so this controller is going to use account service as a mark object. So in this case, account service is a dependency object, so we need to mark it. Okay, so the one way you can create a mark object is using mark annotation. So in our previous case, we use in fact the mark method to create a mark object, right? More convenient way of doing it is in fact using mark annotation. Okay, so that is the same thing as calling a mark method with the dependency class object. Okay, so we are creating, so basically this account service mark object gets created and injected here in your testing code. Okay, and then we also want to use account controller object as as a test target object, right? So when marking is involved, you are going to use not only just the auto-wired, you are going to use inject marks annotation. That means you want this object to be injected with these marks. That's this is what inject marks is all about. Okay. All right. So we have created a mark object. Now we should be able to use this account service mark object. It's just like regular account service dependency. Okay. Now, in order to use this guy in before, what you have to do is you're going to call init marks with this. Okay, so what it means is that you're going to call the static method of Makito annotations, passing your own object here. Basically, you are asking these guys to set things up in basically creating a mark object. So that should be done for each testing. Okay. All right. Now let's see how we can test get balance of first account method. Okay, so here we are going to train our mark object first. So when check balance is called with the account number 1, we want it to return 1000. Okay, so that's how we train our service object. Okay, and then we are going to call get balance method, right? So inside the get balance method is going to call service object of get balance check balance method. Okay, and then we just compare whether balance is in fact 1000. So we just make sure the expected result is the actual result, and then we verify, meaning we want to make sure our mark object is in fact called once. So this is the the another fine-grained control in terms of how many times it should be called. So verify this mark object check balance method is called just once with this value. Okay, so we just want to verify. If somehow check balance method of the mark object has not been called at all, then all the testing goes smooth, right? So that's the reason we want to verify. Okay, and we also say we can also actually add another verification. Verify normal interactions with the mark objects. After we call check balance, there should not be any other interaction with the mark object. Okay, so this is basically unit testing of your get balance for of the first account by using the dependency object, in this case a service account, as a Makito mark object. Okay. All right. So that is exercise 4. So I know it's a bit involved. Okay. So that's basically the testing we're going to do. So we are going to do is testing transaction JPA transaction. Yeah. So this is the code that we have worked on before. Okay, so we have database. Yeah, so it's using database, right? And main application. And so remember the application that we play around yesterday. We have a source account and destination account. We are transferring the $100 and $1,000 and all that stuff. So that's basically the code. Okay, so here we are testing. So JPA. Wait a minute. JPA transaction. And so we want to actually doing a controller, so account controller. So this is the one that I showed you. Okay, so this is in fact the same code I explained in the slide. Okay, so you have a mark object, and we have inject marks. Okay, and then we have before. So every test should call init method of this object, and then here we are basically train the mock object, and then we call the get balance method about target. So basically, we want to test get balance, the get balance method behavior. So if you take a look at the source code, if you go to source code get balance, here it's actually calling the account service mock object, right? Okay, so there is not much of a the business logic here, but what we want to test is that we want to test only the code in this get balance without the real dependency object. Okay, all right, so that is the exercise, and we just learned this code. This code actually is something I just mentioned. Okay, so I'm going to give you guys 5 minutes to do this exercise. Spring provides other miscellaneous testing annotations. So here we're going to take a look at a couple of those. Timed. So you can use the timed annotation to specify the timeout. Okay, so if the testing doesn't finish within the specified duration, then the test fails. Okay, so in this case we are going to specify the testing should finished in 1000 milliseconds. Okay, otherwise it's a failure. And repeat. So if you want to test, if you want to run the test multiple times, you can use repeat annotation. So in this case, I want to run this test 10 times. Okay. All right. So that is the exercise 5. So yeah. So we are going to perform testing of testing MVC project, and we are going to perform timeout. Okay. So that is testing MVC. Oh, what is a testing MVC? Oh, there is not. Oh, maybe it's actually in the XML directory. Let me just check. And Spring for testing unit. Okay, so yeah, it is actually on the samples XML deprecated. Okay, and I didn't think. Yeah, I guess I have not put it to the Spring Boot. Okay, so let's actually import that project from project. XML. Okay. Yeah, I'm gonna just testing MVC. Okay, so here what we are gonna test is on the service. So we are gonna go to under testing and the service here. So that one is JUnit context test. JUnit context test. If you take a look at this guy, yeah, okay. So we have a timeout test of this guy. So 1 millisecond. So if that doesn't work, run as and the JUnit test, and okay, looks like it succeeded. So maybe we'll actually change it to. We'll change it to, oh, then that is a repeat. Yeah, that is also repeat as well. Yeah, so the repeat 5. Okay, so you should be able to actually see the repeat. Okay, this is the code. Yeah, so timeout execution. So instead of 1000 seconds, you're gonna just try just 10 milliseconds, and that should time out failure. Okay, right click, run as JUnit. And this time, yeah, it failed. Okay, yeah, so so timeout exception right here. Okay, it took 14 milliseconds instead of 10 milliseconds. Okay, so you might actually change it to even smaller if your machine is okay. There you go. All right, so I'm going to give you guys about 2 or 3 minutes to try the exercise.